Welcome back to Einstein's Mechanics. In this episode, we are going to talk about multiplication of matrix or matrix multiplication. In a situation where we are given two or more matrices to multiply, how do we go by it and what is the way forward? So let's assume we have a matrix A and we are going to represent the members of the matrix by A, Ij for matrix A. And we have the order of matrix A as M by N. And another matrix B is also being represented by Bij. Let's say matrix B has an order of NR. So N rows, R columns. So if we multiply matrix A by B, we are going to get a matrix C in order of Cij. The members of this matrix C that we are getting from the product of A and B is in Cij, and the order from A and B is going to be MR. Are we okay? This is very simple and an approach we use in multiplying matrices. What we mean here is, looking at the order of matrix A, it is M and N, and the order of B is N and R. So after the multiplication of A and B, we are getting an order of M and R. There's a trick and a trend here that we should figure out. What do we need to follow before we do multiplication of a matrix? First, to multiply matrices, to multiply matrices, to multiply two or more matrices, this is the condition. Number of row or number of column, pay attention, number of columns of matrix A should be equal to, so matrix A column should be equal to the number of rows of matrix B. This condition needs to be satisfied before we can do multiplication of any two or more matrices. The number of columns of matrix A, meaning the first matrix in the multiplication order, and should be equal to the number of rows of matrix B, meaning the second order. So for example, what we are saying is, if we have matrix A multiplying by B, the number of columns in matrix A should be equal to number of rows in matrix B. If we have D multiplying matrix C, this is also equal to number of, this is possible if number of columns in D is equal to number of rows in C. Anything apart from this cannot help us to multiply matrices. So look at here, we are multiplying A and B. This means M is the row, N is the column. N here is the row, and R here is the column. Are we okay? So A multiplying B was possible because the number of column of A, which is N, is equal to the number of row of B. So N columns for A, N rows for B, they are equal. So multiplication is possible. Do you think from here B multiplying A is also possible? Let's see. For B multiplying A, B has N rows, R columns, and A has M rows, N columns. And the rule is saying the number of columns of A of the first matrix, which is this, number of columns is R, should be equal to number of rows of the matrix B. This is the matrix B, the second matrix. The B here or A here does not mean anytime you see matrix A, it should be. We are saying the first A or the first matrix in terms of the multiplication arrangement. B, the second matrix. So here, the column is not equal to the row of the second one, meaning multiplication of B and A is not possible, but multiplication of A and B is possible. I hope you see the trend. This is very interesting and very easy to identify. So let's move further and see something. So let's say we have these two matrices A, B, C, D, E, F, multiplying another matrix, alpha, beta, and a certain V. This matrix, is the multiplication possible? Let's check the order. The first one has an order of 2 by 3, and this has 3 by 1. The number of columns of the first one is equal to the number of rows of the second one, meaning this and this are equal. Multiplication is possible. And after the multiplication, your results, the size of the answer should be what is left, 2 and 1, meaning the size of the answer is going to be 2 by 1 matrix. So we saw here that after the multiplication of A and B, we are getting a size of the first row M and the last column R. Is that clear? All right. So now that we understand the scenario of how the size is going to help us do the multiplication, let's try to multiply this and see how best we can do that. So to multiply this, we say we are going to get a size of 2 rows, 1 column. So multiplication from this is going to give us 2 rows, 1 column. After this and this are equal to help us go ahead with the multiplication. So this is what we are going to get for the multiplication. We are expecting 2 rows by 1 column, meaning on the first row, we are going to pick this row A, B, C and multiply with the first column. Are we okay? So this is what we are going to do. You take your A, you multiply it with the alpha. So on the first row, first column, we have A multiplying alpha. On the first, we are not done. Now we come to B for the same row, same column. B will multiply the beta. So plus B multiplying beta. Then C will multiply the V plus C multiplying the V. Are we good? Now we are done with first row, first column, because we are expecting 2 rows and 1 column. So the column is just 1, but we are expecting 2 rows. So we come to the row 2 and perform the same operation on the 1 column we are expecting. So row 2 is also going to be the same trend, D multiplying alpha plus E multiplying beta plus F multiplying the V. So this is the size of it. So we have 2 rows and just a single column. Are we okay? So the rule is established. Let's look at real life examples where we can perform these operations. So from this example, say we have a matrix A equal to 1, 1, 0, 0, and we have matrix B. Multiplication of matrices is quite confusing, so pay attention and listen carefully. So we are to find AB and BA. So our solution. But before we start, A, B, is it possible? Let's check the size. Matrix A has a size of 2 by 2 and B has size 2 by 2. So the number of columns on the first one is equal to number of rows on the second one. So it is possible to multiply these two matrices. So after multiplication of these two, we are going to get a size of 2 by 2. The result is 2 by 2 matrix. So AB is going to be our AB is going to be, let's get it clear. We know that multiplication is possible. AB is going to be this matrix A. Check your arrangement. Don't say B first, A second. No, it will give you different answer. You arrange it in order of what the question is asking you. So 1, 1, 0, 0, multiplying matrix B, which is 1, 0, 1, 0. So we are expecting a 2 by 2 matrix as the solution. So we need 2 rows, 2 columns. This is what we do in performing the multiplication. The first row here is going to, each one is going to multiply, and we are going to work with the first column. This first row works with this first column. Are we okay? So the first position, we are expecting an answer of this form: A, B, C, D. Are we okay? So to get the value here, which is the first position, A11, we use the first row because it is on the first row and it's also on the first column. So first row for this, multiplying the first column. So this is what we are going to do. This one will multiply this one. So that will be 1 by 1 plus this one will multiply this one, another 1 by 1. So we are done with this point A. We can go to the point C. It is on the first row, second column. So we use the first row, the second column. So meaning 1 multiplying 0 for the first row, second column, plus first row, second column. We are going to use this 1, 2 to multiply this 0. So 1 multiplying the 0. So we are done with the answers we are expecting on the first row. We come to the second row. Since we are working with second row, we pick the second row here. So second row, B is on the first column. So second row, first column. That will be 0 multiplying 1. 0 multiplying 1 plus this 0 by this 1. The D, second row, second column. So second row, second column. That will be 0 multiplying 0 plus 0 by 0. And our final answer is going to be 1 by 1, 1. So here will be 2. And if we solve it well, here is also going to be 0, 0, 0. And this is the answer, which is a 2 by 2 matrix. Are we okay? So this is how the multiplication is done. Let's look for BA. So multiplication of B and A. We are going to arrange it how it looks like. Our B is 1, 0, 1, 0. And our A is 1, 1, 0, 0. The multiplication, since this is a 2 by 2, this is a 2 by 2, this and this are equal, meaning we are expecting an answer of 2 by 2. Are we okay? All right. So here we will take, because we are expecting the same 2 by 2 like this, the first point, we are targeting the first row, first column. So first row, first column, that will be this one multiplying this one. 1 by 1 plus first row 0 multiplying this 0. 0 by 0. We are done with the A part. The C part, which is first row, second column. Still first row, second column. That will be 1 by 1, this 1 by 1, plus 0 by 0. Are we okay? All right. So the second for the B, second row, first column, second row, first column. So that will be 1 by 1 plus 0 by 0. The same thing here, 1 by 1 plus 0 by 0. And the final answer should give us, this supposed to be 1. Here is 1. We have 1, 1. So do we see that B multiplying A is not equal to A multiplying B? This is 2, 0, 0, 1, 1, 1. Are we okay? Know how to use the columns and the rows to do your analysis. Are we okay? So let me ask if this matrix multiplication is going to be possible. 2, 1, 2 by 2, 2, 0, 1. Is it going to be possible? Let's look at the size. This is 3 by 1 and this is 2 by 2. The number of columns on the first one is not equal to the number of rows on the second one, meaning multiplication is not possible for this. Are we okay? All right. So let's look at another example where we can get this from. So example, we are to compute for AC and CA if possible. If possible. If possible, because the order may not match and multiplication may not be possible for these matrices. So we have matrix A to be equal to, we have 1, negative 3, 0, 4, and negative 2, 5 as matrix A. And matrix C is giving us, we have 8, we have negative 3, 2, negative 1, 5, 10, 0, negative 7, and we have 3, 2, negative 4, and 5 for that. So we are to see if it is possible to multiply A by C and C by A. So solution, let's check. First, AC. But let's do if the size is true. A is 2 by 4 for the size, 2 by 4. And C is 4 by 3 for the size. Meaning the number of columns on the first, which is the A, is equal to number of rows on the second. Meaning multiplication is true, can be possible. And after multiplication, we're expecting an answer of 2 by 3, which is 2 by 3. The answer should be a matrix of 2 rows, 3 columns. Are you okay? 2 rows, 3 columns. So let's get to work. So I will write my matrix again as 1, negative 3, 0, 4. I also have negative 2, 5, negative 8, and 9. This matrix is also there as I have 8, 5, 3, negative 3, 10, 2, 2, 0, negative 4, negative 1, negative 7, and 5. This is going to be a little bit of work, but we will try and do that. Let's see. So we are expecting 2 rows, 3 columns, meaning something like this: 2 rows, 3 columns, A, B, C, D, E, F, something like this, right? Which is 2 rows, 3 columns. So you can, in order to be perfect with your multiplication, you can start from the beginning this way. The answer or the size you are expecting, you write it somewhere so that you work according to something like this. So to get my A is on the first row, first column, meaning I'm going to work with the first row, first column. Are we okay? That is going to give me this 1 by 8. Are we good? That's going to be 1 by 8, and we go. So we have 1 by 8, negative 3 by this negative 3, because first row, first column, plus negative 3, negative 3, plus 0 and 2. 0 multiplying by 2, plus this 4 multiplying negative 1. The first A, which is first row, first column. Are we okay? All right. We can look at the B part, which is on the first row, second column. So still working with the first row, second column. So that is going to be first row, second column, 1 by 5 plus negative 3, negative 3 by 10 plus 0 by 0 and 4 by negative 7. 4 by negative 7. We come to the C, which is first row, third column. Still first row, third column. So that's supposed to be 1 by the 3 plus negative 3 by 2, negative 3 by 2 plus 0 by negative 4, 0 by negative 4 plus last one, 4 by 5, 4 by 5. Are you okay? So we are done with the first row. Let's look at the second row. Looking at the D, so D is on second row, first column, second row, meaning now we are going to work with the second row and the first column. Are we okay? So with the second row, we are going to have the negative 2 multiplying 8 plus 5 by negative 3 plus we have this negative 8 and 2, negative 8 and 2 plus 9 and negative 1, 9 by negative 1. So that's for the D, second row, first column. Now E, which is still second row but second column. So second row, second column. That is going to be negative 2 by 5 plus 5 by 10 plus negative 8 by 0 plus 9 by negative 7. And with the F, second row, third column, second row, third column. That is going to be negative 2 by 3, negative 2 by 3 plus 5 by 2, 5 by 2 plus negative 8 by negative 4, negative 8 by negative 4 plus the last part, which is 9 by 5, 9 by 5. Are you okay? There's a bracket over there, so we can see that we cannot perform our operation. So there's a bracket here. So this can be reduced to, after punching everything for the A part, you are going to get 13 for the A part. Are we good? So here is going to give us 13. This place is going to give us negative 53. And this part is giving us 17. Here is negative 56. We have negative 23 and 81 as A multiplying C. See, this is order 2 by 3. Are we okay? So now let's check for matrix CA. Matrix CA. Is it going to be possible? Let's look at it. So this is matrix C. We have matrix C here. 8, negative 3, 2, negative 1. 5, 10, 0, negative 7. 3, 2, negative 4, 5. And A, which is 1, negative 3, 0, 4. And we have negative 2, 5, negative 8, 9. Let's check the order. So the order for this is 4 by 3. And the order for this is 2 by 4. The number of columns on the first one is not equal to number of rows on the second one. Therefore, CA cannot be multiplied. It's not possible. Are we okay? AC is possible, but CA is not possible. So this is how multiplication of matrix is done. You check for the parameter number of column on the first matrix, which is A. We call it A. Let's take it as the first matrix for the multiplication is equal to the rows, number of rows on the B matrix, which is the second matrix. If it is equal, then it is okay to multiply. If it is not, you cannot multiply. Thank you for watching this episode, and kindly subscribe to the channel and like our videos. More episodes ahead.